Hey programmers, Alvin here. Right now I want to go over a Python solution for this tree pathfinder problem. So hopefully you already watched the approach video. If not, highly recommend you do. And I'm going to jump right into the code. So to me, the most reasonable way to solve this one is to do it recursively. And typically, I'd say that's a rule of thumb for all of your tree problems that deal with pathfinding. But don't quote me on that, right? And so we'll start with our base cases. So I'm going to need a base case for when I actually find my target. So if root val is equal to the target, then what should I return? Well, I need to return a path, and the path is represented by a Python list containing all the values that I can take to get to that target. So if my root val is equal to my target, well, then just return a list containing that value. I guess you could have also thrown in target because they're definitely the same. Nice. And what also feels good about this if statement is I can think about my base case as also if it's its own input. And so imagine that I just gave you a tree with just a single node. If your target was that one node, then the path would just be an array containing, or a list containing, that single target. Cool. And then beyond that, I know I'm going to do this recursively, so I'm going to need to make some calls, right? So pathfinder of root left on target, same thing for root right. Something that you should start to feel comfortable doing is you may not know like the big picture of like what your final code's going to look like, but you are definitely aware of what patterns must show up, right? So I'm going to need to definitely call recursively on my left and right. And then from there, we're like, all right, it looks like my target doesn't need to change, right? I always look for the same target. And I'll think about what these calls return, right? I either get back null if I can't find the target in the left subtree, or if I can find it, then I get back a list representing the path to the target. Cool. And so based on what these calls return, I'll go ahead and check it. So maybe I'll call this my left path, like this, left path, and right path respectively. And bear in mind that these variables of left path and right path, they are either lists or null. And I need to actually verify whether they're null or not, right? So I'll check over here maybe if my left path, and by null I mean none, I guess, right? So if my left path is not none, then it's a list, right? So if this if statement is true, that means I found my target in my left subtree, right? And so what do I want to return? Well, I want to return a list that represents the path to that target. And so I know I have a partial path in left path. I need to just put myself, so put root.val at the front of that path, right? So you've seen me use this syntax before. I can create a new list literal, spread out or splat the elements of that current list, left path, and just put myself at the front of it, root val, just like this. Cool. So this is just creating a new list, taking all the original elements of my left path, and then putting root val at the front. And I just write symmetric code for my right path. So we'll call this guy our right path. And bear in mind that in the problem, they actually tell us that the tree contains unique values. So that means a value only appears once in the tree. So I'd only find my target in either my left path or my right path, but not both, right? Because in just one of my subtrees. But it could be the case that it's neither. So sometimes we want to return none if we just can't find the target at all. In which case, we should handle that over here. So if we make it past these two if statements and we don't return either, then by definition, we cannot find our target at all in this subtree. So I'll just return none. Cool, so this code's looking pretty good. There's one thing we should be aware of in terms of the complexity I did mention in the approach video, but let's go ahead and run it and see what we get. So we'll run it through some test cases. So it looks like I'm getting an error. It says none type object has no attribute val. Pretty common bug when it comes to writing your tree algorithms. And it's probably the case where root is none, right? Because there are definitely some trees. For example, if I look at this tree, let's say root is the C node. If root is the C node, I don't hit any base case, right? And so when I calculate my left path, I'm calling pathfinder of root.left. If root is C, then root.left is none because C has no left. And that would throw an error, right? Because if I'm making a call and root is none now, I say none.val. and that explodes and gives me an error exactly on line 8. Cool. So like all of our tree algorithms, typically, especially if it's recursive, we need to handle the case. All right, before you even do any of this logic, it could be the case that your root is actually none, and in which case you could just return none. In this problem, like returning none represents the fact that we did not find the target, or we cannot find the target in this subtree. Right? So if you have an empty tree, right, none represents an empty tree. If you have an empty tree, then you definitely can't find the target. So just return none. So that should be a nice fix. Give that a test now. Cool, and we're passing most of our test cases. And it looks like we did pass all of them, but you may notice for this last example, we have a pretty large elapsed time. Definitely something spiked over here. And so we'll take a look at what test 06 is. It's a very large tree, right? So looking at this little stub they have here, looks like they just programmatically create a massive tree. This tree only has right pointers, so it just goes 0, 1, 2, 3, all the way to like over 19,000 nodes, so it's really big. And then from there, they're looking for, looks like value 16281, which would be somewhere within this chain, this tree, because they're just counting by ones, right? And so we should be able to return that path. What's obvious for this large input, our code is kind of slow, right? One thing I mentioned in the approach video was to be aware of any list operations you do. And in particular, I can identify these lines as the culprit, right? So basically, if I look at this line and I just isolate it, I'll think about what's the runtime of that line, right? So I know that doing this syntax, right, splat left path, that takes an existing list and it basically unpacks all of its inner items, right? So let's say that my left path was of size n, this entire expression would run in O of n time, right? And that's this line itself. Now I think about all of the calls I make. If I'm going to have n calls, and any particular call basically iterates n times, I'm looking at n squared as my runtime. Cool. So this is a common constraint or common issue you might have for your problems that recurse and also return lists as output. And so I'll show you a fix for this. So instead of creating a new list every time, right, this copies over a list and creates a new one. If you want to have like the fastest possible runtime, although it will probably add some just like complicated pieces of code, you will have to just basically insert your elements into a single list over time, right? So don't create copies of lists. And so what I'll do to fix it here is maybe I'll just go ahead and I'll mutate my existing path. So if my left path is none, then I'll say, all right, left path append and add to it root.val. And then I should just be able to return left path because now I definitely put root val on the inside. One thing you might notice is technically append will add your root val to the end of the list, so the right-hand side, which means that I'll end up with things backwards. And so I'll need to come up with another fix for that. But at least append runs in O of 1 time, right? If I inserted at the front of a Python list, that would also take up inefficient O of n time, because inserting at the front of a list would have to shift all of my indices over, right? If I insert at the front, then index 0 has to move to index 1 to index 2 to 3, and so on. And so we'll just have a fix like this for now, and then we'll course correct once again. Something that you should start to get comfortable with is, have many renditions and iterations of your code, right? Just change it over time. So I like to make small changes and then keep on course correcting. So I'll give this a shot. Probably will get some reverse output, right? Yeah, so we expect ABE, we gave back EBA again because we're inserting or adding our root val at the end of the list. But I'm pretty confident that now I'm not copying over many lists. So at least this will run, it seems, in O of n time overall, right? The entire recursion. And so what I would do to fix this is just make a main function that reverses the final output. And let's say you're doing this on like a coding challenge platform or in an interview. I think it's really important that you don't change the function signature that they're going to test. So in this problem, like our specs are going to test a function called Pathfinder. So maybe I'll rename the old recursive function, like underscore pathfinder. Pretty common notation in Python. Typically, if you, for those of you that don't know, if you name a function with an underscore, just as like a style point, it kind of indicates to other people reading your code that, hey, you shouldn't really invoke this function top level. It's like a helper function. And so my main function will be the regular pathfinder. So all I need to do is go ahead and call my underscore pathfinder function. And I know it's going to return some result. So I'll call pathfinder, pass along the same root and target. And I need to verify whether result is none, because if it's none, then I should not reverse it, because that would break my code. But if it's a list, I should reverse it, right? So if result is none, then we shall return, I guess, the result, which is, I guess, none. Maybe I'll just write it like this. Seems more obvious. But otherwise, if result is not none, then it must be a list, in which case I can reverse it. So I can return. Python reverse syntax is pretty slick. I'll just say the name of the list. And maybe you're familiar with like the slice syntax, right? So typically you can give like a start and end for like a range you want within your list. You can also give a third argument representing how you want to step. If I step by -1, that would reverse it. And I want to basically have the entire list and only reverse it, right? So I'll just say blank blank and then -1. Cool, so that should just reverse the list. Technically, this syntax creates a new list that is reversed, but that's okay because I'm just doing this reversal step once at the end, right? I'm not doing it within the recursion. So that code looks pretty good. So I'll give this a shot now. We'll run all the test cases, see what we get. Nice, and we have a much better elapsed time for that test 06. This code would be an O of n time, right? So for this recursive step by itself, the entire recursion, because I make n calls, and any single call is just O of 1 because append is basically free now. This entire recursion is O of n, and then when I do the reversal at the very end, that's also O of n, but they're not nested, so I don't multiply them. So I'm basically looking at, in terms of time complexity, O(n) plus n, right? Which simplifies to just a single O of n. Cool. So there we have it. Do bear in mind for the future this little optimization that we made, right? Typically, when we're kind of creating many lists by copying them over, you're going to incur like some runtime penalty. So maybe figure out a way where you can just add to an existing list. That being said, whenever I'm doing some new problems out in the wild, what I'll typically do is focus my initial energy on just creating a working solution. So maybe it's a slow one. And then I'll analyze my code according to Big O. I'll take note of any expressions or pieces of code that are inefficient, and then I'll make changes to those expressions, right? I like to work on my code in a very incremental way, and I recommend if you're kind of breaking into data structures and algorithms, you tackle it in a similar way.